Alright, this is an example of principal component analysis, also known as factor analysis. For this example, I'm going to be using final 2 data, which you can pull down from the website. Our first step for a principal component analysis is to run the KMO function, which we have to create the KMO function in order to do. After we've done that, we'll run a few principal component analysis to figure out how many variables we want to deal with. Then we'll limit our analysis to that number of variables, and then we'll go through and identify which variables seem to matter. So step 1, load some data. In case you're curious, I'm using final _2 RCC. Alright, now that we've done that, generally speaking, it's a good idea to run a summary on data pretty much whenever you open it. Alright, so I've got some factors here: speed, accuracy, toughness, evasion, yeps, yarps, yebbles, yarks attempted, yarks made, and fouls. Some of those words make sense, some of those words don't make sense. It's alien frisbee ball, so that's okay. What we're curious about is how many underlying factors can explain all of these variables. So some of these have an obvious relationship. Yarks attempted and yarks made. You shouldn't make more than you attempt, and we can imagine that accuracy might have something to do with that, assuming accuracy means what we think it does. So with all of that, we are going to run some factor analysis and see if that quick analysis turns out to be right. So pasting this KMO function in, which is long and nasty. Now I can use KMO, and I'm going to run a KMO on my data, and unfortunately I have to scroll all the way up. It says, hey, KMO's good. We're good to go. Okay, so now that I've done that, I want to find out how many variables I want to interact with. So I'm going to run a principal analysis up to the length of my data set. That's the code to do that. And it says, hey, there's some smoothing or other weird stuff going on, which we'll consider in a second. And as I run this, I come up to, well, at most there's 4 variables, because 5 and 6 don't have anything to do with anything. Okay, so based on our logic, we could say, you know, there's 2 really strong ones, but because it really just drops off to zeros there, I'm going to run this at a 4. So I'm going to say, alright, length is 4. I'm going to make this my second variable, not that it really matters. And I'm going to go with varmax, because my goal is to spread the variation among as many variables as I can. So PC2. Alright, so we have a 0.42, a 0.34, a 0.13, and a 0.1. Okay, I feel alright about that. So looking up here, then, all I'm going to do is identify kind of what the big numbers are in each setting. So 94, 94, 94, 94. Okay, so my first component seems to have something to do with speed, accuracy, attempts, and fouls. Okay, and then we would have to bring some human knowledge to that and try to understand why that would or wouldn't make sense. But those are the really strong ones in that first component. The second component seems to deal with evasion and yeps and yebbles. Okay, so something might underlie those 3. Our third seems to really only deal with yarps. Maybe a little bit of toughness. Toughness and yarps are the only 2 that could be argued to be there. And our last one is entirely yarks made. Nothing else is even close. Okay, so when we consider what that means, we would be able to clump those variables together, as I said, and then we would have to know something about the game to make more decisions based off of that. Now, just for your interest, I can post the code that made that data very quickly. So this is everything that made that. Unfortunately, it's going to throw errors. Maybe I'll post it separately. So I had 3 factors, and then I combined them in 2 different ways. So speed, which is here, was a combination of A and B. Accuracy, which is here, was also a combination of A and B. Yarks attempted was a combination of A and B. And fouls was a combination of A and B. So it did a really good job of identifying which ones were in fact A, B. there were no other factors that were just A and B. All right. My second one was evasion. Evasion was B and C. Yeps was B and C. And yebbles was B and C. So it did that perfectly. It didn't miss any. My third factor it identified was yarps. Yarps were A and C, and A and C was the only A and C. So it successfully identified all of the pairs I used. Then this last one here, Yarks made, is a janky equation. So it has your attempts, it has some random in it, it has some accuracy in it. So it stands to reason that that would show up as a separate piece. It should have had some overlap with accuracy, but it really didn't have a ton because it was kind of a random piece based off of the fact that it was also based on attempts, and attempts were based on A and B. Anyway, that one's its own mess. I'll paste that one in for you just so you can see how nasty that one looks. So I will post that little bit of code for anyone who's interested in the Python. Other than that, that's the end of this one. Hopefully it made some sense.